welcome Professor Rishikesha ji, who has kindly accepted to give keynote address to this audience. I will particularly welcome Professor Haribabu, Professor Manohar Rao, Professor Krishna Ravi Srinivas, my colleagues from the department and colleagues from the DST-CPR and students from sociology department, PhD students, postdoctoral fellows, and MA integrated students, and other students from other departments as well for joining this inaugural session. And I thank you at the outset for your interest in this particular field, that is STIs in India. So I just introduced this theme of this symposium, one-day symposium, which is being held on hybrid mode. India is going to celebrate its 100 years of independence in 2047, exactly 23 years from now. If you look at the science, technology, and innovation scenario in the country, it presents a picture of contrast. One can convincingly say that today India stands tall in science and technology among the leading nations of the world. Its achievements in S&T field is immense. The contribution of science and technology policies in placing India among the top countries is immense. However, a critical look at the scenario also presents that India could have done much more than what it has achieved so far. Standing tall on the contributions of S&T researchers, policymakers, etc., Indian S&T can in fact take giant strides in the years to come with appropriate STA policies and right research and development ecosystem in the country. The idea that STI is essential for economic progress and societal transformation drives STI policy and practice. Challenges due to globalization of STI, liberalization of economy, importance of IPRs, thrust on innovation and valorization, and rapid diffusion and adoption of technologies, including information and communication technologies, are of great concern in formulating STI policies in India now. The growing significance of technoscience, importance given to innovation and STI, and convergence in technologies indicate that traditional approach towards science and technology is changing. There is an impending need to augment STI ecosystem to deliver technologies and solutions that address the multiple needs of society. The Center for Policy Research at the University of Hyderabad, supported by DST, has been working on science, technology, and innovations in India, focusing on formal institutions and informal institutions as well. It also has been focusing on mainstreaming the grassroots innovations and traditional knowledge systems in the country by finding out the process of their scouting, validation, value addition, and intellectual property regimes, along with the current policies pertaining to such innovations in the country. Problematizing innovations, we are undertaking research on STIs, and as part of this exercise, we are holding this one-day symposium on the theme STIs in India towards innovating futures. In the forenoon session of the symposium, we intend to discuss STI ecosystem in formal institutions in India, the challenges faced by the research institutions and academic institutions in mainstreaming their innovations from the perspectives of both academicians and institutions. The second half of the day is earmarked for discussion on grassroots innovations emanating out of non-formal sources. Once again, I thank you all, and also thank Professor Rishikesha ji.
Thank you, Professor Reddy. We are honored to have some distinguished speakers with us for this session today. I would like to welcome our speakers who have generously agreed to share their expertise with us. So, Professor Rishikesha T. Krishnan is there online with us. Professor Rishikesha Krishnan is Director and Professor of Strategy at the Indian Institute of Management, Bangalore. He was earlier Director of IIM Indore. He is currently the Ramcharan Chair Professor in Innovation and Leadership, and earlier held the Jamuna Raghavan Chair in Entrepreneurship at IIM Bangalore from 2007 to 2010. Professor Krishnan has studied from IIT Kanpur, Stanford University, and IIM Ahmedabad. His main areas of interest are strategy and innovation. He has been listed in the Thinkers 50 India list of most influential management thinkers from India. Apart from academic publications, Professor Krishnan has written 2 books. 8 Steps to Innovation, Going from Jugaad to Excellence, co-authored with Vinay Dabholkar, which won the Best Book Award for 2013-14 from the Indian Society for Training and Development, and From Jugaad to Systematic Innovation, the Challenge for India. Professor Krishnan has extensive corporate board and advisory experience. He is currently on the boards of the National Payments Corporation of India, Wheels India Limited, and the Higher Education Financing Agency. He has served on several committees set up by the Government of India and prominent industry associations related to innovations in India. He is a member of the CII National Committee on Technology, Innovation and Research and the CII National Higher Education Committee. Professor Krishnan was a member of the expert committee set up by the Government of India in 2017-18 under the chairmanship of Justice B.N. Rishikesha to propose a data protection framework for India. Professor Krishnan co-founded one startup and was the CEO of another. He has been on the jury of the Economic Times Startup Awards. He is currently on the advisory board of Your Nest Investment Advisors. Now, I would like to invite Professor Krishnan to give keynote address to the session.
Yeah, thank you. Thanks a lot for inviting me. At the outset, my compliments to the Center for Policy Research at University of Hyderabad. I think this is a very important juncture at which to study science, technology, and innovation in India. And my best wishes to all the faculty and staff and students who are involved in this activity. Today, I will be speaking a bit on technological innovation in India. Obviously, the landscape of science, technology, and innovation is quite broad, and it's difficult to cover all of these in one talk. So I have just made a choice out of these different areas to focus my talk on technological innovation. And specifically, I'm going to try and understand where do we stand in India as far as technological innovation is concerned. So that will be the main agenda of my talk this morning. This is largely based on my body of work over the last 25 to 30 years. Two of these books were mentioned in the opening introduction, From Jugaad to Systematic Innovation and 8 Steps to Innovation. But of course, these books are now quite old, so there's a lot of work we have been doing after that, which will form the basis for this presentation. So let me start with a very simple question, which I think we all know the answer to, but it's worth elaborating a little bit. Why should we be worried about technological innovation at all? Why is it important? Well, clearly there are multiple reasons why technological innovation is important. For one, a lot of studies in economics show that economic growth is largely a factor or a resultant of increases in productivity coming from technology. We also know that there are strategic reasons why technological innovation is important. For example, we don't want to be at the mercy of anyone else when it comes to certain critical equipment, like, for example, indigenous aircraft carrier. We would also need to avoid holdup. You might remember during COVID that while we had the capacity to produce vaccines in India, some critical raw materials were not available, and our External Affairs Minister, during his visit to the US, had to ensure that some of these raw materials and intermediates would be available to our Indian manufacturers. We also have several local problems that we need to solve at low cost, given the challenges in affordability in India. For example, we have a very low cost yet effective rotavirus vaccine, which was developed indigenously, and we are aware of many such other solutions. And last but not the least, we would like to drive industry leadership in certain chosen sectors. Indian motorcycle industry is a good example, where the Indian players have created a strong position for themselves in the domestic market and are also doing reasonably well in the international market. And this was possible only because they have developed their own innovation capabilities as far as technology is concerned. So this is just to quickly sum up why technological innovation is important. So now let me come to the core question of our talk today, which is where do we stand? And of course, how does this look like in terms of a trajectory? How has this changed over time? Now, if you go back to the time soon after independence, you will recall that our cornerstone of our industrial policy at that time was to create manufacturing capacity in certain critical mother industries like steel, capital goods, etc. But at that time, we did not have the technology to enable many of these industries. So our first challenge was to learn how to produce, for which we had to borrow or adapt technology from other countries. Once we had brought that technology into India, there was no guarantee that the technology would just work on its own, because we were often bringing them from countries with different climatic conditions, different raw materials, different skill sets, etc. So we had to learn how to produce efficiently. Still later, we had to also realize how do we get to the technological frontier as far as the production of those products, whether it be steel, fertilizer, petrochemicals, etc. So if you look at the first 30 to 40 years after independence, you could see that our focus on innovation was largely on the first three steps, which were broadly focused on process innovation. It's only after liberalization, maybe from the 90s onwards, that we come to the last two steps designated in this chart, which was saying that we were looking at how to improve products as well as design new products. So Indian innovation capabilities in a way encompassed product innovation only from the 1990s onwards. So just keep this perspective in mind, because it's important if you want to understand how innovation in India has changed over time. Now, if you try to understand for any country, what are the different factors driving innovation? Normally, we look at some kind of a framework like the National System of Innovation. And you could see in this diagram here that we are really looking at three sets of factors which drive innovation in any country or region. The first is the availability of the critical inputs for innovation, could be people, funding, knowledge, infrastructure. So this is really the input or the supply side. But the demand side is also important. We are interested in looking at, is there an incentive for innovation? Ultimately, at the end of the day, firms are the critical agent in innovation, because they are the entities that take ideas to the market. So firms will innovate only if there is a chance of appropriability, if they can get the benefit of innovation, if the capital markets and other markets reward innovation. And often they'll innovate only if there's competition, only if there's pressure to innovate quickly. So that's as far as the demand side is concerned. But there is also an intermediate part of this framework, which is looking at the firm itself, because clearly the firm is the key agent here. So unless the firm is structured, designed, managed, led in such a way that it encourages innovation within it, you will not see innovation happening. So you could call this the capacity to innovate. How have these three sets of factors changed over time? One could certainly argue that thanks to the liberalization of the economy, the incentives to innovate have certainly improved. The way this market values innovation has certainly increased over time. But one could also argue that on the other two sets of factors, on the input side as well as the capacity to innovate side, there are still significant challenges. And I will come back to these issues as we go along. Let's look at some data to try and understand, where do we stand on innovation? And here again, largely we are focusing on technological innovation. The first thing you could do is compare, of course, with China, because that's a large country with whom we are often compared. And here the data I am citing is largely from the Global Innovation Index report. This is a figure most of you would be familiar with, that gross expenditure on R&D in India has been hovering around this 0.7 to 0.8% level for several years now. And it so far at least hasn't shown any sign of reversing that trend. Whereas the gross expenditure on R&D in China as a percentage of GDP was about 2.4% in the comparable year. So we are talking about a fairly wide range. OECD countries might have as much as 3%, but India is certainly at the bottom end of this range, which is something we know quite well. If you look at the distribution of R&D across industries, that the industries in which we see the most R&D in India are drugs and pharmaceuticals, transportation, and IT. This again might not be new to many of you, because we all know that pharma has historically been one of the innovative industries in India. This also points to another challenge that in many countries which have advanced technologies in their mix as far as the economy is concerned, you are more likely to see industries like semiconductors, electronics, IT, hardware, and so on at the peak of R&D expenditure. And the fact that we don't have a significant presence in many of these industries is also reflected in the fact that our leaders, as far as innovation is concerned, are pharma, transport, and IT. Again, another important fact about India that we all know is that R&D in India is largely driven by the government. Certainly, more than 50% of the expenditure on R&D in India comes from the government as a source. This is quite a contrast to the other countries you can see in this chart, whether it be USA or Germany, France, or even China for that matter. You will find that the government accounts for a much smaller proportion of the R&D spending. And this continues to be a challenge as far as India is concerned. Just to put the spotlight on which are the companies that spend the most on R&D, this is 2022 figures from the Global Innovation Index report. And what you see is that India's largest spender on R&D is Tata Motors. It spent about 2 billion euros in that year. Number 2 and 3 are pharma companies, Sun Pharma and Aurobindo Pharma. But very interesting when you contrast it with China. Huawei, which is China's largest R&D spent about 8.5 times the amount that Tata Motors spent. Of course, this partly just reflects the fact that Huawei is in a very technology and R&D intensive industry, and India doesn't have a significant presence in such industries. Now, one important and interesting trend we might like to note is that traditionally, even the patents granted by India largely went to foreign inventors or to multinational companies. But some recent data suggests that this trend is beginning to change, at least as far as applications is concerned. In fact, this study by Sanyal and Arora shows that by 21-22, domestic applicants accounted for about 44% of the patent applications at the Indian Patent Office. Of course, if you look at patenting abroad, you will again see it's largely driven by multinationals. About 70% of the patents issued by US PTO to Indian inventors go to inventors who are working for multinational corporations. Not surprisingly, when you look at high-tech exports, which is again a reflection of technological innovation in a way, China is significantly larger than India. This, of course, refers to high-tech manufactured exports, not services. So India had high-tech exports of about $21.6 billion in 2020 compared to about $757 billion of China. So you can see that's it's just big order of magnitude higher than what we see in India, which again is just underlining the fact that we don't have a significant presence in a number of industries which are very technologically intensive. Of course, the overall ecosystem matters. And we all know that having high quality academic institutions is usually an important driver of technological innovation. This is something that's probably well known to most people in this audience. India's best ranked institutions in the QS ranking, typically IITs and IISc are all in the 150 to 200 range, whereas China has universities even in the top 50, Tsinghua, Peking, and Fudan. Another important dimension about innovation in India, of course, is frugal innovation, which is probably not quite the technological innovation that we normally think of as R&D driven. But nonetheless, frugal innovation is an important phenomenon because it enables low-cost solutions to local problems. And many studies have shown India to be a leader in frugal innovation, whether it be thanks to Arvind Eye Care, the Jaipur Foot, reverse engineered vaccines, low-cost heart surgery, etc. So this, of course, is a strength of India's that we might like to sustain going forward. This is just the first part of my talk, just to give you an overview of where do we stand. So typically our R&D intensity is low, partly because we don't have presence in the most R&D intensive industries. We also face challenges as far as academia is concerned. Now, let me give you another comparison, and this comparison is between the top 10 innovations in the latest decade of 2011 to 20, compared to the decade earlier, which was 2000 to 2010. We did a study to try and identify the top 10 innovations in 2011 to 20. And the 10 that we identified were the biometric identity system Aadhaar, Rotavac, which is the vaccine that I mentioned to you earlier, along with Covaxin, which are both low-cost vaccines developed for the Indian market. UPI, which is the Unified Payment Interface, which has created a nationwide operator agnostic payment system, which enables people across different platforms to transact with each other. I will odd one out in this analysis is Tejas Networks, which has been a leader in optical networking equipment, probably the only company in India which has a significant presence in a very high-tech manufacturing area like this. Another important innovation in 2011 to 2020 was the Government Electronic Marketplace, or GEM, which enables low-cost public procurement in a much simplified manner, more like an Amazon. Interestingly, we found that one of the most impactful innovation programs in the decade 2011 to 2020 was the aspirational district programs supported by Niti Aayog, which made a very creative use of competition between aspirational districts, the use of data, and coordination between the center, state, and local government to drive improvement of human resource indicators in these selected districts. Another area where India has done extremely well is in test kits and diagnostics. And of course, some of you would know that in the year 2013, the first Indian drug to go all the way from discovery to launch, which is essentially saroglitazar developed by Zydus Cadila, completed this entire cycle. This was an important development because while India embraced the GATT agreement way back in 1995, and thereafter reversed the old patent regime, it took quite some time. It took almost 20 years for an Indian drug or a new Indian molecule to go through all the levels of testing and reach the market. Another important area where we have seen innovation from India is, of course, in terms of diagnostic equipment. For example, you have or diagnostic platforms. You have Forus, which has distinguished itself in the detection of eye problems. And you have Niramai, for example, which has created a very robust thermal imaging-based platform for early detection of breast cancer. And of course, no description of innovation in this last decade is complete without remembering India's outstanding performance through Mangalyaan, which was one of the lowest cost Mars missions in the world, and of course achieved it right the first time, which was quite a record compared to other countries. So these were what we found to be the 10 most impactful innovations in India between 2011 and 2020. And we would also love to compare this with the innovations in the previous decade. The innovations in the previous decade, interestingly, were largely products of this type, whether it be the Nano, the Advanced Light Helicopter, the Reva, the Tata Edge, etc. So you will see that all of these are discrete engineered and manufactured products. If you compare the 2 decades, what do we see? The first thing we see is that the latest decade has been characterized by high impact public innovation with a focus on creating important platforms and public goods like UPI. Clearly, digital and data are important drivers. Healthcare has been a major arena for innovation, and COVID has been a major driver of this, of course. Ironically and somewhat interestingly, there's been a reduction in big ticket, high visibility corporate innovation. You might remember that in the previous decade, products like Nano caught the public imagination, but we haven't seen a Nano type innovation in the 2011 to 2020 decade. Startups are emerging as major innovators, and that's an important change. At the same time, deep tech innovation is still an issue. We are still not seeing enough companies really engaging in deep tech innovation. Some important enablers of all of this have been the digital backbone and NPCI, which has driven UPI innovation. We have iSpirit and other volunteers who have created the platforms and public goods. By the way, this is an interesting model. While it is the public platforms that have been created in this decade, it's interesting to note that these have not been created through our public R&D infrastructure. India continues to have a large network of public R&D labs, including CSIR, DRDO, ICAR, etc. But many of the most impactful innovations were created by volunteer groups, more like open source, and not through the established institutions which have been created over the years. Then, of course, we have programs like Startup India, which have enabled startups to get a lot of support and funding. And of course, government coordination initiatives have helped bring demand and supply together. Now, against this backdrop, I would like to share with you some important recent developments that could potentially change the innovation landscape going forward. One of them, of course, is the PLI scheme. The PLI scheme is an important driver of growth in certain critical sectors. Under the PLI scheme, we hope to attract investment in some sectors which have not been developed as rapidly as they should. The advantage of this will be once a manufacturing ecosystem is created, perhaps the R&D and technology ecosystem will follow. Of course, it remains to be seen whether that sequence happens the way it is expected to, but it is certainly important that we are putting investment in creating certain new industrial sectors which could be more R&D and technology intensive in the future. Particularly, semiconductors is an important dimension of PLI. And you might remember that in June 2023, we had the first major investment announced from Micron, which is investing in a chip packaging plant in Gujarat, investing almost $1 billion. So this is a significant development because it might point to the development of an indigenous semiconductor industry in India. We have also seen that the Anusandhan National Research Foundation has been created with a target of dispersing about 50,000 crores over the next 5 years. This should provide a major fillip to R&D based innovation in the country. Though, of course, at this point of time, the source of this 50,000 crores is not entirely clear, as the government has clarified that only a portion of this will be from the government and the remaining money is expected to be raised from private industry and foundations and other philanthropic organizations. We've also seen that there are new signs of a thaw in terms of technology availability. GE and HAL signed an MOU, I think a little over a year ago, where HAL will have the technology to produce engines for the LCA aircraft. We also, of course, know that there is the successful Chandrayaan-3 mission, which has acted as a great source of motivation and inspiration for all our youngsters, and has also been a clear demonstration of India's prowess in science and technology. The Indian space policy announced last year and, of course, updated just a few days ago, aims to promote private sector participation in the space economy. The idea is that ISRO will focus only on the emerging and R&D intensive dimensions of space, but many of the routine activities will be undertaken by private enterprises. This should again result in a diffusion of innovation capabilities across the private sector in space and should hopefully lead to more innovation in the years to come. We have seen some green shoots of all of this already in Skyroot Aerospace, which has developed some rocket technologies, and also Log9 Materials, which is working on some of the critical materials required for lithium-ion batteries. Let's hope these are just the first signs of an emerging, vibrant R&D and tech infrastructure, which will be able to power innovation in India in the years to come. Let me come to the last part of my talk, which is, okay, now given all of this, what do we need to do? I think in the introduction, it was mentioned that we have this target of Vikasit Bharat in 2047, and that's where the country would like to reach. So how do we look at all of this going forward? What is it that we need to do? Let me start by talking about the government. In my view, the government has an important role to play in fostering technological innovation. We already have examples of government programs which do this effectively. One of them is the entire portfolio of programs launched by BIRAC, a special purpose vehicle under the Department of Biotechnology. What's special about BIRAC's programs is they cover all the stages of innovation, and they cover all types of entities, whether it be a startup, established company, an academic institution, or a research lab. And BIRAC's programs have been quite successful in fostering a technological renaissance in the biotech sector. One hopes that the examples set by BIRAC will be emulated in other sectors, and this holds out the potential for technological innovation and development in other sectors as well. Government-run programs also have a big role to play. I'll give you the example of the Collaborative Automotive Research Program, which was launched by the Principal Scientific Advisor's Office about 20 years ago. This was a government program to support technology development in the automotive industry. It brought research institutions, academia, and companies together around specific R&D themes. And a useful output or outcome of this was that we even had startups which have now developed into companies based on technologies that came from academia. For example, Professor Suryanarayanan, whose picture you can see in this slide, used his expertise to develop control-intensive products for small engines and powertrains for a variety of applications. And this came about out of the car program. So I think using this as a template, we could look at some ways of driving innovation in the years ahead. I referred earlier to the importance of coordination between demand and supply. One is likely to see innovation happening when there is a better understanding of what are the needs. During COVID, some consortia which were set up, including the National Biomedical Resources Indigenization Consortium and the Consortium for Affordable and Rapid Diagnostics. Both of these were supported by the government, but were run through incubators and other available platforms. These brought demand and supply together and enabled India to meet the requirements of many things which were in short supply during COVID. We also see an emerging role for regulators. The Reserve Bank of India, for example, has already shown that it is willing to provide regulatory sandboxes to enable testing of new ideas in the finance sector. These sandboxes are important because it's not possible to let unregulated activities happen out in the broader banking sector. But the sandboxes like these have enabled testing of ideas in retail payments and cross-border payments. And hopefully we'll see this kind of concept being extended to other areas as well. Government procurement also plays a critical role as far as driving innovation is concerned. You might remember during COVID, it was the procurement activity of the government which enabled both Serum Institute and Bharat Biotech to ramp up their production of the vaccines without having to worry unduly about demand and their ability to reach out to the market. So certainly, government procurement has always played an important role in supporting technological innovations. Let me come to the second major entity as far as technological innovation is concerned, which is established companies. I'll start with an interesting example. This is a company I have studied in some detail. This is Praj Industries based in Pune, started by Dr. Pramod Chaudhary, whose picture you can see there. Praj started with a very simple problem. The problem they started with is that Indian sugar manufacturers had a lot of waste, essentially in the form of cane molasses. And there was the potential to process this cane molasses into alcohol through a fermentation process. So what Dr. Chaudhary and Praj did initially was they imported technology to enable this transformation to happen. But once they imported the process, they realized it didn't work very well in India, partly because the molasses were very dirty. They weren't stored in very good conditions in the sugar factories. So over time, they had to work on adapting this to the Indian context. But they also realized over time that they had the ability to fingerprint molasses and waste, and they could make their process more flexible to handle different kinds of inputs. They became a specialist in process equipment and turnkey solutions. Ultimately, their dream became to do waterless fermentation, steamless distillation with zero pollution, and to become a major player in the second generation biofuel business. Many of you might know that today when we buy petrol in India, it is blended with ethanol. And you'll be interested to know that Praj is working with the three major oil companies, Indian Oil, BPCL, and HPCL, to set up huge biofuel facilities using the technological expertise and know-how which Praj has developed over the last 30 plus years. So this is a very interesting transition, or you could say a progression of starting with, of course, imported technologies like many other companies, but today being at the leader's end as far as biofuel manufacturing and processes is concerned. We essentially need more companies that can emulate what Praj has been able to do which is to progress step by step to developing significant technological capabilities. Another example could be Biocon, which started as an enzyme company in the food enzyme business, later went into the pharmaceutical area, has over time built on the expertise they already had in fermentation technology to be one of the leaders in the biosimilars business globally. Of course, you don't always need to follow this track. You could also be a good absorber of technology. Eureka Forbes is a good example. Eureka Forbes, as all of you know, has a huge presence in the water purification market through a brand called AquaGuard. It also means that Eureka Forbes is a formidable potential supporter for the diffusion of new technology. And in fact, global water purification players have been reaching out to Eureka Forbes to try and commercialize their technologies. And it's Eureka Forbes' large market presence which makes them a very attractive candidate to undertake this. As far as large companies are concerned, another important area to focus on is working with startups. Today, we know that startups around the world are often the source of a lot of very interesting ideas. And large companies throughout the world are also trying to figure out what's the best way of collaborating with startups. This is an area where Indian companies perhaps have some way to go. Multinationals like Cisco, whose example I've given you here, have demonstrated that it's quite possible to drive this in a very structured manner. For example, Cisco has a program called Launchpad in India, where they work with cohorts of 8 to 10 startups at a time. The reason they collaborate with startups is also very clear. They want to track new technologies. They want to associate with technologies or products that are complementary to their own. And they also want possible additions to their sales engine. But they have essentially developed the ability to work effectively with startups to further these objectives. While India has a large number of startups, one of the big challenges for startups is to match their technologies and products with the needs of the market. In other words, I would say they need to solve the right problems. Here's a good example. This is a company called Vigyan Labs, which won the NASSCOM Innovation Award a little over a decade ago. The founder of Vigyan Labs realized that data centers are today a big challenge as far as their contribution to global warming is concerned. And he realized that data centers can waste as much as 90% of the power they pull off the grid. So he worked on an algorithm to reduce power consumption by data centers. And you will be happy to know that his solution is today part of being used as part of one of India's largest public sector banks. To give you another example, one of our alumni, Anjan Mukherjee, he realized, of course, something that we all know, that a lot of water in India is pumped up from hand pumps, but water in hand pumps often has high levels of bacterial contamination. He came up with a process which is completely chemical-free, which ensures 99% plus physical kill of microbial contamination to eliminate waterborne diseases like diarrhea, cholera, and typhoid. And this uses a cavitation-based technology, which doesn't use any chemicals or any other dangerous substance, and can be easily retrofitted in a hand pump in a matter of a short time. You can, in fact, see in the picture that that's what Sanjan is doing in this particular picture. Startups also need to collaborate effectively with large companies to be able to reach the market. In fact, you might remember that MyLab, which was one of the first small companies to get approval of its COVID test kit, was able to scale up rapidly during COVID, thanks to its collaboration with the Serum Institute and Syngene, two large companies which had the ability to scale up effectively. Let me now come to the last set of organizations I want to talk about, academia and research institutions. One of the big challenges for academia is, of course, how to work across the spectrum. That is, how to take on problems that ultimately have industrial and social impact. Professor Bob Langer, who's a legendary figure at MIT, gives some hint on how this can be done. It's a lot about how you choose the project. For example, when Dr. Langer chooses a project, he looks for 4 elements. It should be centered around a huge idea, which is conceived by recognizing a critical social need that could be met by inventing a platform product. It should lead to a seminal paper based on research to establish the science underlying the product concept. It should have the potential to come up with a blocking patent. derived from patent disclosures written in parallel with the research process. And of course, he works in the area of biotech, so preliminary in vivo studies in animals should be able to demonstrate the efficacy of the research. So anyway, the bottom line of this is I think more of us need to choose problems that are what might characterize engaged scholarship. That is, they have both interesting research implications, but they also have utility. And those are the kind of problems which we need to focus on. We also need to create a new generation of innovators who are good at identifying these problems. The Stanford India Biodesign Program launched some years back between All India Institute of Medical Science, IIT Delhi, and Stanford Design School, provides a good example of this. They brought together smart young people from diverse disciplines, put them in teams. They did a comprehensive needs assessment across a primary health center, district hospital, and a tertiary hospital like AIIMS, identified critical needs, finally filtered them down, and then worked on devices to address those needs. And many of these have won patents. Some of them have got commercialized. Academia also needs to change its internal incentive structures and the way it interacts with industry. We have good examples in India already. IIT Madras is a good example. IIT Madras Research Park, which was set up more than a decade ago, provides an excellent arena for collaboration between IIT and the industry. Industry can get space in the research park only if it shows evidence of intensive collaboration with IIT, and there's a scoring system to ensure that this happens. In parallel, IIT has also changed its measurement and incentive system for faculty, so that today doing industrial research is recognized as important as doing research which leads to publications. And it has a very dynamic and very contemporary startup policy, which encourages startups by both faculty and students. All of these together have enabled IIT Madras to create a very dynamic environment for innovation going all the way to translation and commercial impact. And then, of course, we also need to look at some new models. Traditionally, our research institutes and industry have been quite far apart. Maybe we need to look at ways of bridging the gap. The Fraunhofer institutions in Germany show one way in which this can be done, but perhaps we need to find ways in India of finding effective bridging mechanisms to enable academia and research take their innovations to the market. Just to summarize, in short, I think what can be said is that India has made significant progress over the years as far as technological innovation is concerned. But at the same time, significant challenges remain. These challenges are largely in terms of getting into new areas which are much more R&D intensive. Companies developing strong innovation capabilities internally, which will enable them to drive strong multi-year R&D programs. Ability for academia and industry to work together, which needs changes in their behavior on both sides. But certainly on the academic side, changes in incentive structures and the whole performance measurement system would be a useful change going forward. Both academia and startups need to be more particular about the way they choose problems to work on. In particular, they would benefit by choosing problems which have industrial or social impact, as I had explained in my talk. And the government, of course, continues to have a role to play in terms of supporting end-to-end innovation. BIRAC's programs provide a good example, but there are many other similar examples we could look at, which need to be adapted across different government departments to drive innovation in the future. So in short, while we have a good foundation, there's a lot of work left to be done if India wants to be a leader in technological innovation by 2047. So let me stop here. Thank you. I don't know whether your setup allows for any questions, but if it does, I'm happy to take some questions. If not, you can, of course, mail me or send me some questions and I'll be happy to answer them.
Thank you, Professor Krishnan, for such an insightful talk. Now, if anybody has any questions, you can. Yeah.
Hello, sir. Sir, my name is Sudeep Kesarwani. I am from Political Science Department. I have interest in IER, International Relation. Sir, can you just grow some insight about what is the condition of military-industrial complex and how the DRDO is working on this science and innovation research? And at international level, it is always said that we are behind the Europeans and we are behind the some Asian countries like China and South Korea in the military development and export. So what is the lacking behind, what is the reason for India to lacking behind these countries? Can you just grow some?
Sure. Yeah, thank you. See, I think India historically had a policy where all equipment or all products with any kind of defense application had to be made in the public sector. So you would recall that therefore companies like BEL or HAL or other public sector companies were the primary places where defense equipment was being made. Of course, apart from ordnance factories and other entities which are directly under the Ministry of Defense. Over the years, many of these companies had been reaching out to private companies more in terms of supplying components and parts of their overall products, but not really developing products as a whole. Same thing would be true of ISRO as well, which has developed a very good supplier base over the years. However, a major change which has happened in recent years is the opening up of the defense sector to the private industry. Now we have private companies which are not only making products for India, but also possibly making them for export. So for example, we have companies which are making howitzer guns. We have companies which are now looking at building aircraft and helicopters. Many of these are, of course, to start with in collaboration with foreign companies. But it is, I guess, to be expected that these companies will develop their own capabilities over time. Again, when you look at shipbuilding, we have Indian companies which are now beginning to make ships and even submarines for the Navy. So in short, I think there has been a significant change in the scenario as far as defense production and technology is concerned over the last decade or so. Of course, it remains to be seen how this evolves over time, whether Indian companies will become global leaders or they will be largely just focusing on Indian requirements. DRDO's role, I suspect, has declined over time because with these private companies coming into the fray, I don't know how many of them are working directly with DRDO. DRDO still has a role, but that might be more in some specific technologies where we are not able to access technology from other countries. DRDO itself is currently under some kind of review. I think government has set up a committee. So let us see what are the recommendations which come out from that committee and what is the change plan that the government finally formulates.
That's a wonderful session, sir. And we had this privilege of hearing you, at least online. Thank you for that. I have a kind of, it's not exactly a question, but your observations or comments, sir. So where do you see these conventional universities in this entire innovation ecosystem that is emerging in India now, sir? And what could be the kind of how to motivate or how to incentivize, how to bring them on par with other institutions you have just now mentioned, whether DRDO or other corporate groups? Yeah.
Well, I think there are multiple dimensions to that, Professor. I think you also are aware of that. I think one thing is, of course, while many of the universities do good work in basic science, we should strengthen that and make sure that the work which is being done is actually at the global level. And we should continue to have a strong presence in basic science. There's no doubt about that. However, there's also quite clear that we need to focus on more translation type activity, which is not an easy capability to develop. Even in institutions like IITs, it has taken many years and a lot of effort. So there are 2 or 3 things I think one could do in this direction. The first one is encouraging a lot more startups, also encouraging faculty to get into startups. That will automatically push them to start looking at more application-driven work. And we also therefore need to look at perhaps making some changes in our performance measurement and incentive system for faculty, where even working with startups or coming up with commercializable ideas should also get credit in our university assessment system. I think that's an important thing we need to do. We need to create much better infrastructure. So, the Atal Innovation Mission has this concept of tinkering labs, but tinkering labs are very basic. If you want a more sophisticated innovation to happen, probably you need more sophisticated labs where students and faculty can try out new ideas. Faculty also need a lot more exposure to the industry because industry is moving ahead quite fast. We should encourage faculty to spend more time outside the confines of the university or the institution. There are many opportunities for that. I'll just give you a simple example. Confederation of Indian Industry organizes a lot of industry trips for their industry members. This is partly intended to help the small scale players develop some of the high-end technologies and so on. So they take them to visit some of the large industries. Now, many of our academic institutions are also members of CII. So there's nothing to stop us from sending our faculty also as part of these industry visits. But essentially, we need to create mechanisms so that we start linking the capabilities of the faculty with the problems of the industry. And that will happen only if we have greater interaction and discussion between the two. So I would strongly urge that, this should be an integral part of the working of the university. Faculty should be encouraged to spend more time in industry, working on projects, things like that. So I think there are a lot of things we can do. You just have to, but I think we might have to think in a fresh way, and we might need to loosen some of the, very tight knots we have tied ourselves in if we want to make all this happen.
Professor, I don't know whether it's a question or I'm trying to validate myself. So do you really think that private-public partnership will solve some of these issues? That's the first part. And second part is, for example, IMB is known for X. And instead of creating another entity or instead of pushing another institute to achieve that level of achievement, so can we not have collaboration, or maybe can we not have some kind of tie-up with IMB in terms of doing similar kind of research work? And then we can also identify some of the thirst areas. If IIT Madras is good at something, so we'll further try to develop IIT Madras for only that particular area of research, maybe on par with the global standard, and then developing IIT Delhi or IIT Bombay for something else, and University of Hyderabad for something else, wherever we are standing in number 1 or number 2 position. So now what I feel is we are working in silos, and there is no integrated approach that is happening among the government institutions. That is the first thing. And second one is even between the private and public also not much is happening. So do you really think that these two proposals can solve some of the issues that we are witnessing at this moment? Thank you, Professor.
Yeah, let me respond to your second question first. I think it's a great idea to develop focus areas if they are clearly visible. That I think happens in a natural way itself. I mean, I know your university, you have quite well-known centers of excellence in certain areas. Those may be the natural starting points for doing a lot of collaboration and so on. So I think that should happen. It is also happening in a way in certain government programs. If, for example, if you take telecom, government is very keen that India should have its own technology for 5G. And for that, what they have done is on 6G and all these next generation of telecom technologies. So they have identified that certain IITs already have competence in this, IIT Madras, IIT Bombay, etc. So they have tried to bring those institutes together to create a kind of cross-institutional team to address some of those issues. So and where the government is involved, I'm already seeing some efforts in that direction to bring the expertise which is already available and try and get them to work together. Your other point about collaboration between institutions, you see, I think the only challenge is that, as you probably know, collaboration between institutions is not that easy. Because each of us have our own way of working, we have our own culture, our own rules, our own processes. So sometimes making, I would probably say that people who are co-located, that will be easier to start with, particularly having institutions in different cities or different states. Collaborating might be a little tricky. So maybe you should look for collaborations in Hyderabad and in and around, perhaps in Telangana itself. Maybe that would be a good starting point rather than trying to collaborate across long distance. Public-private partnership is also not at all easy. And that term itself is quite a challenging one. So I would suggest, sorry, I don't mean any offense to you, but let's not worry about those terms. I think the best thing is step out of the university. That's my general advice. So, you might have heard, there was in Central Leather Research Institute, the first director was one gentleman called Dr. Naidoma. He was a very famous leather technologist and later became Director General of CSIR. He used to say, I feel happy when I go to the lab and I see nobody in the lab. And instead, I hear that they are actually at the site of the industry client. That is what used to make him happy. He was happier to see people at the factory rather than in the lab. How many of our institutions will be happy with that? I don't know. So I'm just leaving you with some ideas to think about.
Thank you very much, sir, for this a very interesting talk. So I am Oroshmita. I am from Sociology department. Like I'm a PhD scholar. So you talked about various challenges that we face in India in terms of having more innovation, technological innovation, and also the challenges that we face in terms of our position in the global in terms of our position in the technological innovation in the at a, even larger global scale. So you talked about all the challenges that largely the scientists or innovators they face. As a sociology student, I really want to know, like, where do you see a responsibility role of a sociologist or a social scientist, for example, in this policy research, in basically in innovation studies, and how do you think they could contribute positively to both in the growth of innovation, at the same time also bringing in terms of equilibrium, in sort of trying to a balance between both growth and also the societal need, as well as yes, India is a very diverse country. So yeah, like balance between the growth and basically the development that we need in India.
Well, I think sociology has, first of all, let me clarify. I'm not an expert on sociology. So if I say anything which doesn't make sense, just excuse me. But, it just seems to me that, for example, the previous gentleman, he asked some questions about public-private partnership, collaboration between institutions. I thought all of this is part of organizational sociology, right? They're all part of how organizations coordinate with each other, work together. So that's just one very obvious example of application of sociology. The whole startup ecosystem is driven by certain social phenomena, certain social aspirations, and so on. So I think I haven't seen good sociological studies on the startup culture in India or startup entrepreneurs and so on. Yeah, a lot of people have looked at from management angle and so on. But from a bigger social phenomenon point of view, I have not come across any good studies. So I think there is plenty of scope to do some interesting work. Then, of course, the whole nature of work itself is changing, as you know, with all these new technologies coming in, the way organizations function is changing. So I personally think there's a lot of work for people with background in sociology, and maybe some of this would also go into anthropology and related disciplines. But there seems to be quite a lot of scope for work in these areas.
Thank you, sir. And we have one more question on the chat from Madan. He's asking that another area of innovation in construction is the development of smart buildings that use sensors and data analytics to optimize energy use and improve the comfort and safety of occupants. The use of advanced materials such as biodegradable composites and self-healing concrete is also enabling more sustainable construction practices. Will the interaction between people and machines alter many aspects of production and have an impact on the economy and ecosystems?
Yeah, I'm not an expert on materials and construction, but what I hear from people in the real estate business is that construction methods are undergoing a lot of change. Technology is coming into construction as well. That is going to certainly have an impact on the labor intensity of construction, even the construction methods. Traditionally in India, we have used a lot of unskilled labor or semi-skilled labor in construction. With the increasing use of technology and new materials and so on, skill requirements will also go up. So whatever requirements the construction industry has are likely to change. But I'm sorry, these are all very high level answers because I don't know too much about construction industry, but I think it's safe to say that it's going to change. That I think is fairly safe to say.
Thank you, sir. And we're taking one last question.
Okay, fine.
Sir, good morning, sir.
Morning.
Sir, how to inculcate social impact thinking, especially in innovation ecosystem across higher education institutions? So whereas social sciences streams, I don't think so that exactly, I don't know whether they're highly, interested to think something, I don't know, technology or, science angle, or they do only focus like as a, mono a stream like, policy research. How to integrate these, three together, like social sciences, technology and policy, etc. Especially in, higher education system, sir.
Yeah, I think it is largely going to happen only if you can expose your students to the real world. I somehow feel that it's not going to happen sitting in the classroom. You need more field work. I give you an example. So Professor Anil Gupta at IIM Ahmedabad, he every year takes his students for a 1-week trip on what is called a Shodh Yatra. In the Shodh Yatra, every year they go to some one district somewhere across different parts of the country. And during that 1 week, they walk across different parts of the districts, trying to understand local problems, see what innovations have been developed by the local people to solve those problems. They also look at cataloging some of those. They try to see if there are any interesting ideas which can be maybe shared with others in other parts of the country. Essentially, it's a discovery mission to identify problems and link them to innovation. You, I think, need to figure out more ways of trying to do things like this, because you're not going to get social sensitivity and sensitivity to social impact sitting in the classroom. So I don't know how. I mean, I know it's a challenge because you might be having large classes, you might be having many students, maybe difficult to arrange visits for all of them. But I think you have to find some creative solutions of how to do all of this. That is, in my mind, that's the only way you can bridge the gap which you just described.
Professor, one question in online.
Yeah, it all depends on the organizers. I don't mind, but I think they want to, probably they need to close. Okay, you go ahead. The last question, yeah.
Yes. Thank you, Professor. Myself, Dhirendra Sahu. I'm also working under Professor Reddy. Basically, my question and observation is, as you in decade-wise, you present like in an enriching way how society, science, technology, innovation policy has developed. So basically, my question is, as AI, artificial intelligence is embedded in every sector now, whether it is health, whether it is education, everywhere. So there are also one factor is coming, that is risk factor. So how in your tech you will explain about the risk factor of AI?
Yeah, so this is your good question, Dhirendra, but I think the challenge is most of us don't understand AI too well. To be honest, even I don't understand AI too well. What are the implications of AI? Not completely clear. There could be both positive as well as negative. You might have read somewhere that actually President of the US and I think the US Congress, they called some of the tech leaders, that is this tech company CEOs, and asked them to pay more attention to the risks of AI and all that. We are also seeing increasingly regulation coming into play, particularly in Europe. Generally, EU is the leader in many of these advanced forms of regulation. So I think people are getting sensitive to it. Even in India now, we have had one or two cases of deep fakes being used to, misrepresent some of the political and cultural leaders and so on. So here also, I think the sensitivity will come fairly soon that we need to look at that. So I'm sure regulation will be required and probably fairly comprehensive regulation will be required. But exactly what are the contours of that regulation are not clear as of now. I think let's close the session now. So thanks a lot for all your questions. If you have any further questions, you can send me an email. I'll certainly try my best to respond to them.
Yeah. Thank you so much, Professor Krishnan, for patiently taking and answering and all the questions and providing your insights. I express my sincere gratitude to you for taking us through through the illustrious journey of science, technology, and innovation in India. And thank you for sharing inspiring success stories and also providing important lessons and advices along the way. Your talk has also enlightened us to the immense potential the future holds for innovation in India. Thank you so much, sir.
Yeah, thank you for inviting me and all the best to your center.
And thanks to Professor Raghava Reddy and Rajni Sharma for organizing and executing this very important event. And special thanks to Dr. Ram Prasad for the concise and informative picture of DST-CPR. Dear participants, we'll be coming back in 15 minutes. We'll break now for tea and refreshments. Thank you.